So in this video, we'll be discussing another parameter for real gases, which is the Boyle temperature. So ano nga ba ang Boyle temperature? It is the temperature wherein at low values of pressure but not zero, magbe-behave ideally yung iyong real gas, okay? Kahit real gas siya, or at least defined siya ng isang particular equation of state na hindi ideal gas equation, nagkakaroon siya ng values ng Z na equal sa 1, kahit hindi nagre-reach sa 0 yung pressure. Pero, mababa pa rin naman yung pressure na yun. Okay? So, as you can see here in this graph, makikita nyo na meron tayong tatlong isotherms. Okay? So, this isotherm 1, 2, and 3. So, makikita nyo sa isotherm 1 na nagkakaroon lang siya ng value ng Z equals 1 kapag ka yung pressure niya ay 0 na. So, obvious siya dito sa ating graph. So, ganun din sa 3. Okay? So, makikita nyo na nagpo-point lang yung graph niya sa Z equals 1 kapag 0 na yung iyong pressure. So, anong pinagkaiba ng 1 and 3 dito sa 2? So, makikita nyo, merong mga values, okay, na T greater than 1 kung saan yung iyong Z ay equal na sa 1. So, merong ganong klaseng temperature. Okay? So, kailangan lang natin siyang hanapin for each equation of state. Okay? Kasi, regardless of your gas, isa lang naman ang formula ng iyong Boyle temperature kapag ka nagpa-follow sila ng isang equation of state. Bale, per equation of state, may isa siyang formula or may isa siyang expression for the Boyle temperature. Okay? So, ideal gases obviously have no Boyle temperature because it is always Z equals 1 at any temperature. Okay? Lagi siyang nagpa-follow ng ideal compression factor. Okay? So, let's derive the Boyle temperature. So, using this particular expression, we will use the van der Waals equation of state to derive the Boyle temperature of a certain van der Waals gas. So, mag-start muna tayo sa P equals RT over V bar minus B minus A over V bar squared. That's the van der Waals equation. Okay? So, ang gagawin natin, kukunin natin yung Z by multiplying both sides by V bar over RT. Okay? Kasi ang ating Z, so we can see, ay P V bar over RT. Okay? So, this will be Z is equal to, so V over RT times RT over V bar minus B is V bar over V bar minus B. Okay? So, minus A over V bar RT. Okay? So, we can convert this again to an expression that is similar to a certain expression that can be converted to a Maclaurin series expansion. So, V bar over V bar minus B. Multiply natin ng 1 over V bar over 1 over V bar. Magiging 1 over 1 minus B over V bar. So, this can be converted into a series, okay? 1 plus B over V bar plus B over V bar squared plus B over V bar cube plus the infinite series siya of increasing powers of B over V bar. Okay? So, ilalagay na natin siya dito sa term na to. So, Z is equal to 1 plus B over V bar plus B over V bar squared plus B over V bar cube plus, okay, continuous siya, minus A over V bar RT. However, kailangan natin ng expression for Z as a function of pressure kasi nakikita nyo naman sa ating Boyle temperature condition, dapat yung Z ay i-differentiate natin with respect to pressure. So, to be able to do that, we have to use the low pressure assumption. Okay? So, at the low pressure assumption, yung iyong gas ay medyo nagbe-behave ideally. So, V equals RT over P. So, yung RT over P na to, isa-substitute natin siya sa mga values na, or sa mga V bar ng ating compression factor equation. So, Z is equal to 1 plus BP over RT plus BP over RT squared plus BP over RT cube plus Okay, continuous siya. Minus AP over RT squared. Kasi yung V mo ay magiging P over RT. So, RT times RT is RT squared. Now, kunin natin yung derivative ng Z with respect to pressure. So, partial of Z with respect to pressure at constant temperature is equal to B over RT. Okay? Plus, okay, B over RT squared times 2P, okay, plus B over RT cubed times 3P squared plus so mga derivative na yan, minus A over RT squared. So, nawala yung kanyang pressure. Okay? After nyan, kunin natin yung limit, okay, limit as P approaches 0 of this particular differential. Okay? So, the limit, okay, is set, okay, such that yung values mo ng pressure ay nag-a-approach sa 0. Sobrang liit ng value ng pressure na papalapit na siya sa 0. Okay? So, kukunin natin yung mga values ng ZPT at very low pressures. So, all we need to do is to assume that the pressures are so low that the terms involving P are vanished. Okay? So, B over RT na lang matitira kasi wala siyang pressure term minus A over RT squared. Okay? So, paano natin makukuha ngayon yung Z equals 1 na line? Okay? So, makikita nyo dito na yung Z equals 1 na line ay may 0 na slope. So, ibig sabihin, this part, okay, should have Z, P, T, which is equal to 0. So, nangyayari lang yung equal to 0 na yan kapag ka nasa limits ka at P approaches 0. Okay? So, all we need to do now here is to equate this to 0. Okay? Para yung slope ng ating line ay horizontal. Or yung ating line ay horizontal, therefore, the slope is 0. So, therefore, B over RT is equal to A over RT squared. Okay, cancel na yung RT. B is equal to A over RT. Therefore, this temperature here is the Boyle temperature. T is equal to T Boyle is equal to A over RB. Okay? So, that was how you derive the Boyle temperature of a Van der Waals gas. So, Boyle temperature is A over RB for Van der Waals gases. Now, for our sample problem, okay, we will calculate the Boyle temperature for neon as a Van der Waals gas. So, the Van der Waals constant of neon is given, or are given. So, yung A niya ay 0.1441 atmosphere liter squared per mole squared. Yung B ay 0.014 liters per mole. So, just substitute A and B in the Boyle temperature expression. So, this is A, 0.1441 atmospheres liter squared per mole squared. This is R, 0.082056 liter atmosphere per mole Kelvin. And B is 0.014 liters per mole. So, nagka-cancel na yung liters, yung moles, tsaka yung atmosphere. So, matitira dyan ay yung Kelvin. Okay? So, that would be the value or the unit of your Boyle temperature. So, the Boyle temperature is 125.437 Kelvin. Okay? So, now, to test this theory or this particular observation, we will calculate the Z of neon at the Boyle temperature, which is 125.437 Kelvin. So, we will use this particular equation. We will calculate the real and the ideal volumes separately. Tapos kukunin lang natin yung ratio. So, for the solution of the V real, kukunin lang natin yung cubic expression ng ating Van der Waals gas, which is nakuha na natin kanina or in the previous lectures. Okay? So, the real volume is calculated using the solver for cubic equations. That's 2058.571694 liters per mole. Now, solving for the ideal volume, you just have to use the ideal gas equation. So, V bar ideal is equal to RT over P. Makukuha natin ay 2058.571694 liters per mole. So, if you get the ratio, mapapansin nyo, pareho ang values ng real at ideal volume. Okay? So, ang makukuha nyo dyan ay 1. Eksaktong 1 for the compression factor. That's up to 6 decimal places. So, mapapansin nyo, very close sa 1 yung Z. Kasi, maybe there are values here, pero the point is, sobrang lapit niya sa 1. So, ibig sabihin nito, yung Van der Waals gas or yung neon mo, nagbe-behave siya ideally at this particular temperature, 125.437. Tapos, pagka nasa mababang values siya ng pressure. So, 0.005 is considered a very low pressure for gases. Okay? So, see you next video for the next topics.